Hello, this is Serene from Exam Hub Lab. Today I'll be solving Physics Paper 2 AS Level Structured Questions 9702 Paper 2 Variant 2 October-November 2018. Question number 1. A golfer strikes a ball so that it leaves horizontal ground with a velocity of 6 meters per second at an angle theta to the horizontal. The magnitude of the initial vertical component Vy of the velocity is 4.8 meters per second. Assume that air resistance is negligible. Part A. Show that the magnitude of the initial horizontal component Vx of the velocity is 3.6 meters per second. So there is hypotenuse, which is 6 meters per second. And the vertical component of that 6 meters per second is 4.8 meters per second. To get the horizontal component, we can use the Pythagoras theorem. Square of 6 minus square of 4.8, the whole root, and that gives me 3.6 meters per second. Part B, the ball leaves the ground at time t is equals to 0 and reaches its maximum height at t is equals to 0.49 seconds. On figure 1.2, sketch separate lines to show the variation with time t until the ball returns to the ground of part 1, the vertical component of the velocity. Label this line y. So for the vertical component, when ball rises, the initial speed is 4.8, which lies here, and the final velocity will be 0. And this change in velocity is over a period of 0.49 seconds. So after 0.49 seconds, it has a velocity 0. And remember that acceleration is negative 9.81 as it is rising up in air and air resistance is negligible. So constant negative acceleration whilst rising in air. So for this part, we'll have 4.8 here. On the y-axis at time t is equals to 0, and 0.49 seconds later we'll have 0 meters per second of speed at maximum height. A straight line from 4.8 to 0.49 seconds. A straight line because constant acceleration, and negative gradient because it's rising up in the air and has got a magnitude of negative 9.81. For the part when ball starts to fall, this was the part when ball rises up in the air. Now for the part when ball starts to fall, it now has reversed its direction. So our next graph will be on the negative side of y-axis. When the graph crosses x-axis, it means that there is change in direction of motion. So when it starts to fall and returns to the ground, it has an initial speed of 0 meters per second at 0.49 seconds, and again acceleration would be positive 9.81, and that's constant. So again a straight line until final speed is equals to negative 4.8, negative because it has reversed its direction. Now it is moving downwards, so negative 4.8. It takes the ball 0.49 seconds more to reach the ground again, so at t is equals to 0.98 lies here. The final velocity is negative 4.8, so it should reach here. So again a straight line from here, and the gradients of both these graphs should be equal, as the gradient of velocity versus time graphs gives you acceleration, and acceleration is constant for both, but they are in opposite directions. I'll label this line as y. Part 2, the horizontal component of the velocity, label this line x. So for the horizontal component of the ball, it will have a constant velocity, and that's Vx, 3.6 meters per second for the entire period, meaning from the instant the ball starts to rise until ball returns to the ground. Thus for whole 0.98 seconds, speed is going to be 3.6 meters per second. It's going to continue until 0.98 seconds, and this is x. Part C, calculate the maximum height reached by the ball. So this can either be calculated using area under graph, this graph, or because we already know that the initial speed with which it starts to travel is 4.8 meters per second, the final speed it reaches is 0, and the acceleration is negative 9.81 since we're neglecting air resistance. So using the formula v squared is equals to u squared plus 2as, we get maximum height being covered by this ball as 1.174 meters. Part D, for the movement of the ball from the ground to its maximum height, determine the ratio kinetic energy at maximum height by change in gravitational potential energy. So at its maximum height, the vertical component of the speed is 0, but that of horizontal component is 3.6 meters per second. So kinetic energy at maximum height is 1 by 2 mass into the horizontal component of the velocity, which is 3.6 the whole square, and that gives me 6.48 into mass. This is the kinetic energy of the ball at maximum height. And the change in gravitational potential energy is going to be mass into 9.81 into the maximum height it covers is 1.174. That leaves me with 11.517 into mass joules. So 6.48 divided by 11.517, that leaves me with a ratio of 0.563. Part E, in practice, significant air resistance acts on the ball. Explain why the actual time taken for the ball to reach maximum height is less than the time calculated when air resistance is assumed to be negligible. So less time taken for the ball to reach maximum height means that at that instant acceleration is greater, which also means that resultant force is now greater than the only force that acts when air resistance is negligible, which is weight. So we can write that the resultant force is greater than its weight. Because when air resistance is being neglected, the only resultant force we consider is the weight. And when air resistance comes into action, there is weight and then there is force due to air resistance. So that resultant force might be greater than the weight. That results in greater acceleration, and as a result we get less time interval in which the maximum height is being covered by the ball. Question number 2, part A, the kilogram, meter, and second are all SI base units. State 2 other SI base units. So one is current, which is measured in amperes. And the other one could be temperature, that is taken in Kelvin. Part B, a uniform beam AB of length 6 meters is placed on a horizontal surface and then tilted at an angle of 31 degrees to the horizontal as shown in figure 2.1. The beam is held in equilibrium, so the beam is in equilibrium by 4 forces that all act in the same plane. A force of 90 newtons acts perpendicular to the beam at end A. The weight W of the beam acts at its center of gravity. A vertical force Y and a horizontal force X both act at end B of the beam. Part 1, state the name of force X. So force X could be friction, because this tends to always move against the direction of the beam's motion. Part 2, by taking moments about end B, calculate the weight W of the beam. So about point B, there is a weight that will cause anti-clockwise moment, and there is 90 newtons of force that will cause clockwise moment. So we will be ignoring both forces X and Y because the perpendicular distance between these forces and point B is 0. So the rule is that clockwise moment, total clockwise moment should be equal to total anti-clockwise moment. Total clockwise moment is going to be due to force 90 newtons. So force multiplied by perpendicular distance between B and that force. So 90 newtons to this dotted line is 6 meters, that is point B. So 90 into 6. This should be equal to total anti-clockwise moment. Now for the anti-clockwise moment, we need to have the weight vertical component, which is this one, so that we get perpendicular distance between this vertical component of W and this dotted line at pivot B. So this vertical component, before we calculate that, we know that this is 90 degrees of angle and this is 31 degrees of angle. So this vertical component can be measured by taking W cos 31, and this horizontal component is W sin 31. Now what we need is W cos 31. This force should be multiplied with the perpendicular distance between this component of force and the dotted line at pivot B. So from the center until point B, it's going to be half of the length of the beam. So it's going to be 3 meters. And that's how I get weight as 210 newtons. Part 3, determine the magnitude of force X. So the beam is held in equilibrium, so all the horizontal and vertical components of the forces should be equal. Force X is horizontal, so it should be equal to the only horizontal component that exists in this system, and that's of 90 newtons. Because weight itself is acting downwards, and that's vertically downwards, while 90 newtons is at an angle. 90 newtons, we can extend that until here. It has got a horizontal component as well as a vertical component. This angle is 90 degrees. This angle over here is 31 degrees. This is 90 newtons, and what we want is this one. This is going to be sine 31 multiplied by 90. So we can say that since this beam is in equilibrium, this horizontal component should be equal to this horizontal component. So we can write that force X is going to be equal to 90 into sine 31. And that gives me 46.4 newtons of force X. Question number 3, part A, state the principle of conservation of momentum. So I can write that for an isolated system. Sum of momentum of a system is constant. Part B, the propulsion system of a toy car consists of a propeller attached to an electric motor as illustrated in figure 3.1. The car is on horizontal ground and is initially held at rest by its brakes. When the motor is switched on, it rotates the propeller so that air is propelled horizontally to the left. Density of the air is 1.3 kg per meter cube. Assume that the air moves with a speed of 1.8 meters per second. In a uniform cylinder of radius 0.045 meters, also assume that the air to the right of the propeller is stationary. Part 1, show that in a time interval of 2 seconds, the mass of air propelled to the left is 0.03 kilograms. So mass is equal to density of air, which is 1.3, multiplied by volume of air that's propelled to the left in 2 seconds. So volume of air that is propelled is in the shape of a cylinder. So volume of cylinder is equals to pi r square h, where radius is 0.045, and the length this mass of air covers every second is 1.8 meters, which is 0.0115 meters cubed. So this is the volume of air propelled in each second. So for 2 seconds, it's going to be 0.023 meters cubed. This is the volume of the air propelled in 2 seconds. So mass of air can be calculated by taking the product of this volume and the density of air, which is 1.3, and that leaves me with 0.030 kilograms of air. Part 2, calculate the increase in the momentum of the mass of air in B part 1. So initially air molecules were stationary and they get propelled at speed of 1.8 meters per second. So change is going to be mass multiplied by change in velocity, and that's 0.054 newtons second. The force exerted on this mass of air by the propeller, so force exerted is equals to change in momentum divided by the time taken for this change in momentum, that's 2 seconds. And the force being exerted is 0.027 newtons. Part 3, explain how Newton's third law applies to the movement of the air by the propeller. So Newton's third law explains how objects exert force on each other, but in opposite directions. So like here, propeller is exerting 0.027 newtons of force on mass of air. So this mass of air will also exert 0.027 newtons of force on propeller, but in opposite direction. So I should write that air also exerts 0.027 newtons of force on propeller, but in the opposite direction. Part 4, the total mass of the car is 0.2 kilograms. The brakes of the car are released and the car begins to move with an initial acceleration of 0.075 meters per second square. Determine the initial frictional force acting on the car. So resultant force is equal to mass into acceleration, where resultant force in this part of the question involves friction force and the force that's exerted on propeller by air, which is 0.027 newtons. So resultant force is the difference between those two forces, and the mass of the car is 0.2 into 0.075, and we get frictional force as 0.012 newtons. Question before part A. Sound waves are longitudinal waves. By reference to the direction of propagation of energy, state what is meant by a longitudinal wave. So longitudinal wave has got oscillation, parallel to the direction of propagation of energy. Part B. A stationary sound wave in air has amplitude A. In the experiment, a detector is used to determine A squared. The variation of A squared with distance x along the wave is shown in figure 4.1. Part 1. State the phase difference between the vibrations of an air particle at x is equals to 25 centimeters and the vibrations of an air particle at x is equals to 50 centimeters. Okay, so at x equals to 25 centimeters means this is 25 centimeters and this is 50 centimeters. A particle over here and a particle over here. Here I've got two nodes. If I suppose that this is the rest position of the wave, between 25 centimeters and 50 centimeters there are two nodes, so phase difference is going to be of 180 degrees because all particles between two successive nodes will vibrate in the same phase, and those which are out of those two nodes will be in the different phases. Part 2. The speed of the sound in the air is 330 meters per second. Determine the frequency of the sound wave. So the wavelength of this waveform or this stationary wave is 0.5 meters, and the formula for the speed is that speed is equals to frequency into wavelength, and so frequency is equals to speed divided by wavelength, which is 0.5, and so we have 660 hertz of frequency. Part 3. Determine the ratio amplitude of wave at x is equals to 20 by x is equals to 25 centimeters. So at x is equals to 20 centimeters, we have got 2.6 of amplitude square, and at 25 we have got 4 of amplitude square, and we are asked to find amplitude, not the square form. So root of 2.6 divided by root of 4, that gives me 0.81 ratio. Question number 5. Red light of wavelength 640 nanometers is incident normally on a diffraction grating having a line spacing of 1.7 into 10 to the power of -6 meters. The second order diffraction maximum of the light is at an angle theta to the direction of the incident light. Show that angle theta is 49 degrees. So for diffraction grating, we have the formula d sine theta is equals to n lambda, where sine theta is equals to n lambda by d. The maximum order diffraction maximum we are over here having is 2 into 640 nanometers of wavelength, so we'll convert that to meters, and the line spacing of 1.7 into 10 to the power of -6. That leaves me with theta 49 degrees. Part B, determine a different wavelength of visible light that will produce a diffraction maximum at an angle of 49 degrees. So in all visible lights, red has got the longest wavelength. So now some color that produces maximum at a shorter wavelength, which also means that number of orders forming will increase by 1 from 2 to 3. In the previous part, the highest order maximum forming was 2, so this time it will be 3 as the wavelength will be decreasing, so the order should be increasing by 1 as they are inversely proportional to each other. So 2 into 640 into 10 to the power negative 9, this is the previous record. The newer record would be having the maximum order forming increased by 1 multiplied by the newer wavelength, which will be a shorter one. So that leaves me with 4.3 into 10 to the power of negative 7 meters of wavelength. Question number 6, part A, define the volt. So 1 volt is joule over coulomb. Part B, a battery of electromotive force, 7 volts and negligible internal resistance is connected in series with 3 components. Resistor X has a resistance of 5.2 ohms. The resistance of the filament wire of lamp Y is 6 ohms. The potential difference across resistor Z is 1.4 volts. Part 1, calculate the current in the circuit. So voltage across Z is 1.4 volts. Therefore, voltage across both X and Y components would be the difference between the EMF and the voltage across Z. That's 5.6 volts. And their total resistance is going to be 5.2 plus 6, and that's 11.2 ohms. So current is equal to voltage divided by resistance. Voltage across X and Y is 5.6 and their total resistance is 11.2 ohms. That leaves me with 0.5 amperes of current. So this is the current through every component because they are connected in series. Now part 2, determine the resistance of resistor RZ. So resistance is equal to voltage divided by current. Voltage across resistor Z is 1.4 volts. And the current across each component in the circuit is 0.5. So the resistance of resistor Z is 2.8 ohms. Part 3, calculate the percentage efficiency with which the battery supplies power to the lamp. So the power of the battery is going to be the current across it and the EMF of the battery, which is 7 volts. So 7 into 0.5, this is equals to 3.5 watts of battery. Now it asks you to find the percentage efficiency with which the battery supplies power to the lamp. So the power of the lamp is going to be I square R, where I square is the current across that lamp multiplied by the resistance of that lamp, which is 6 ohms. That leaves me with power 1.5 watts. The percentage efficiency is equals to the useful energy or power output divided by total power input into 100%. So the efficiency with which the battery supplies power to the lamp is just 43%. Part 4, the filament wire of the lamp is made of metal of resistivity 3.7 into 10 to the power of negative 7 ohm meter at its operating temperature. In the circuit, determine for the filament wire the value of alpha, where alpha is equal to cross-sectional area by length. So the formula is resistance is equal to resistivity into length by area, where resistance area is equal to resistivity into length, and so cross-sectional area by length is equal to resistivity divided by resistance, where resistivity of the filament wire of the lamp is 3.7 into 10 to the power of negative 7, and the resistance of the lamp is 6 ohms. So this gives me alpha with value 6.2 into 10 to the power of negative 8 meters. Question number 7, part A. The current I in a metal wire is given by the expression. State what is meant by the symbols A and N. So A over here is the cross-sectional area. Of the metal wire. And N is number density of free electrons. Part B, the diameter of a wire XY varies linearly with distance along the wire as shown in figure 7.1. There is a current I in the wire at end X of the wire. The diameter is D and the average drift speed of the free electrons is Vx. At end Y of the wire, the diameter is D by 2. On figure 7.2, sketch a graph to show the variation of the average drift speed with position along the wire between X and Y. So at end X, the average drift speed is 1 Vx. So let me mark over here. And Vx should increase with decrease in diameter as we move along xy because area is inversely proportional to average drift speed. So when d decreases from 1d to 3 by 4 of d, that's moving from x towards y, the new Vx, or the average drift speed, will be equals to 1 by 3 by 4 the whole square. That leaves me with 1.78 Vx. So halfway through x and y, where d has decreased from 1d to 3 by 4 of d, we have got 1.78 Vx. That lies somewhere here maybe. Now when 1d decreases to half of that, our new Vx is going to be 1 by half the whole square. That leaves us with 4 Vx. So at position y, we are going to have 4 times of Vx, which lies here. So we are going to have an increasing gradient with a slope Question number 8, part A. In the following list, underline all particles that are leptons. So this is all theory, which is antineutrino and positron. They make up leptons. Part B, a stationary nucleus of magnesium-27 decays by emitting a beta minus particle and gamma radiation. An incomplete equation to represent this decay is the following. Part 1, state the nucleon number and the proton number of nucleus X. So the nucleon number will remain as it is, which is 27. But the proton number will increase by 1, so that it's 13 over here and negative 1 over here. 13 minus 1 will give you 12. That's the conservation of charge. Part 2, state the name of the interaction that gives rise to this decay. So that's weak nuclear force. Part 3, state 2 possible reasons why the sum of the kinetic energy of the beta minus particle and the energy of the gamma radiation is less than the total energy released during the decay of the magnesium nucleus. So one of the possible reasons is that nucleus X has kinetic energy too. And the second to that could be that an antineutrino is also produced, which has energy. So that was the end of the paper. Thank you for watching.